Hi everyone, I am Santipriya from Department of Mathematics and Statistics, Bhavan Vivekananda College of Science, Humanities and Commerce. This video lecture is on linear algebra for undergraduate courses, which covers lesson 1 consisting of prerequisites for linear algebra. In this lesson 1, I am going to give a brief introduction about the following 2 points. The first one is system of linear equations and the second one is a matrix method to solve system of linear equations. System of linear equations. In your earlier classes, you would have learned, suppose you are given like this some equations, x plus 2y is equal to 5, 3x minus 2y is equal to 7. Solve this. So you know different methods of solving these equations. Or here you can observe there are given two variables x and y. Suppose you may have another system like 2x minus 5y plus 6z is equal to 1, x plus 6y minus 7z is equal to 2. So this is a system which has three variables x, y and z. So solving these systems is nothing but finding the values for x and y which satisfy all the equations in the given system. So you had earlier methods when the number of variables are either 2 or 3, you learned the methods. Suppose if I have more number of variables, that is 4 variables, 5 variables, then the methods what you learned earlier will be difficult to solve the system of equations. So here we will learn how do we use matrix method. Before that, let us see in general what are systems of linear equations. So let me take here two systems. So the first one, I'll have a set of equations like x1 plus x2 minus 2x3 plus 4x4 is equal to 0, 2x1 minus 7x2 minus x3 plus 5x4 is equal to 0, and then let me take 6x1 plus 5x2 minus 7x3 minus x4 is equal to 0. Now the same way, the same equations, I'll take them in this way. Minus 2x3 plus 4x4 is equal to 2. 2x1 minus 7x2 minus x3 plus 5x4 is equal to 5. And then 6x1 plus 5x2 minus 7x3 minus x4 is equal to 9. Now what is the difference you observe in these two systems? The same equations left hand side, but the right hand side is different. This system of equations have right hand side all zeros, whereas this system of equations right hand side non-zeros. All right. Then this system we call it as homogeneous system of equations, and this is called as non-homogeneous system of equations. Now how are we going to solve these systems of equations? Before solving, what do we mean by solution? Let us see. If I observe the first one, the left hand side, the homogeneous system. So I can observe here that in the first one equation, if I substitute x1 0, x2 0 and x3 0 and x4 0, then it is getting satisfied. In the same way, the second equation and the third equation, you can observe that if you take x1, x2, x3, x4 zeros, second equation is satisfied, same as the third equation is satisfied. What do you mean by this? Any system of homogeneous equations always this system has a zero solution. Now let me take the non-homogeneous one. Then can you say that substitute x1 0, x2 0? 0 and this 0, but the right hand side is 2, not 0. So this is not equal. What do you mean by this? 0. This system will not have a 0 solution. It has no 0 solution. Right. Now let me see. Now we are saying that, again let us come for this homogeneous. This has a 0 solution. Then does it have any other solutions? Yes, it may or may not have other solutions. Now let us come for this. Yes, it has no 0 solution. Then what about the solution of that? Then this may have a solution or it may not have no solution. It may not have a solution. If it has a solution, then it will have either a unique solution or infinite solutions. If it has no solution, there is nothing to think about that. Then let us bring the concept of consistent and inconsistent systems. So I'll generalize this like this. System of linear equations. So I have these are homogeneous one and here non-homogeneous one. Then this homogeneous one has unique solution, means 0 solution only, or infinite solutions. That means other than 0 solution it will have some other solutions also. When I have here non-homogeneous one, it has no solution or it has a solution. Has a solution implies unique solution or infinite solution. Then what are consistent inconsistent systems? Equations, I'll say consistent, then inconsistent. Consistent means it has a solution. Inconsistent is it has no solution. So we all know has a solution means it can be either unique or infinite. Then inconsistent is no solution. There is no other case. Then if I take a homogeneous system of equations is always consistent. Why? Because it always has a 0 solution. Then when you take non-homogeneous systems, then they may be consistent or inconsistent. Right. Now let us go to the second point of this lesson. That is, the second one is a matrix method. A matrix method to solve system of linear equations. So here I will be taking a non-homogeneous system of linear equations. So let me take randomly some equations. x1 plus x2 plus x3 minus 2x4 is equal to 5. Then 3x1 minus x2 plus 5x3 plus x4 is equal to 2, and then 7x1 plus 3x2 minus x3 plus 4x4 is equal to 1. So I have a system of equations here which are non-homogeneous equations. How am I going to solve using a matrix method? Here I will build a matrix A. In this matrix A, I will just take the coefficients of x1, x2, x3, x4 in each equation. So let me take the first equation. So what is coefficient of x1 is 1, coefficient of x2 is 1, coefficient of x3 is 1, coefficient of x4 is minus 2. Then in the second equation, I have coefficient of x1 3, and then minus 1, and then 5 1. And the third row is the coefficients of the x1, x2, x3, x4 in third equation. They are 7, 3, minus 1 and 4. Then I'll take this as a matrix which has 3 rows and 4 columns. Then my another matrix which is a column matrix X. What does it have? How many variables do I have here? x1, x2, x3, x4. So I have x1, x2, x3 and x4, and then D. It is D. This is, let me just see. This is a D which has a column that is 5 to 1, which is the right hand side of this system of given equations. So I have three matrices A, X, D. Then the above system 1 of equations now can be written as a matrix equation Ax is equal to D, because if you multiply A with X, so X is it has 4 rows and 1 column. Then D has 3 rows and 1 column. So Ax is equal to D. Now this is giving you a matrix equation 2. So solving here, this system 1 is nothing but solving the matrix equation Ax is equal to D. So we all know from your earlier classes that the solution for this is nothing but finding the values in X, and using the inverse of the matrix we can have Ax is equal to A inverse D. This you learnt in earlier classes. Just find the inverse of A and multiply with the D. But for all the matrices we cannot find inverse. We can find inverse only for square matrices, that too non-singular matrices. But when I see here, look at here, my matrix A is a 3 by 4 matrix, which is not a square matrix. So I cannot use this method to solve this system of equations. Then the method what we are going to have here is, in linear algebra we will use echelon forms of matrices, which I'll explain in my next lesson. How do we use it? We'll write an augmented matrix, that is, it is like this A, D. What does it have? I have already here A, so that is I have 1, 1, 1, and then minus 2, and then 3 minus 1, 5, 1, and then 7, 3, minus 1, 4, this is A, and then I have here 5, 2, 1. This matrix I call it as augmented matrix, and I will reduce this to another form which is called as echelon form, and then I'll give a solution for the system of equations. So that we will see in the next lesson. Thank you.